Title of our project, Prototype Model and Implementation of Structural Health Monitoring. Scope of our project, buildings like hospitals, schools, stadiums which would cause harm to large number of people and are something that has to be taken care on daily basis. This is done in order to reduce the maintenance cost. This model aims to provide accurate information concerning the structural condition. Information obtained from these monitoring is usually used to plan and design maintenance and enhance the safety and damage detection. This model monitors parameters such as wind speed, temperature, humidity, vibration during seismic events and crack depth. Hence, smartphone alerts will be provided and also warning call will be provided to the maintenance staff as well as maintenance engineer when the parameter exceeds the threshold values.
This is the block diagram of our project, and these are the sensors we are going to use in our project, and we are using 80 Mega 328 microcontroller. Here we are going to use ADXL 345 sensor for measuring vibration. It is a small, thin, low power vibration sensor. It is used to measure the vibration in 3 directions. And for measuring and detecting the cracks, we are using ultrasonic sensor. And for measuring the temperature and humidity, we are using DHT11 sensor. And for detecting the high wind, we are going to use Hall magnetic sensor. By using Hall magnetic sensor, 4 magnets are placed under the shaft, and when the magnet detects the sensor, it is going to show 5 volt, and in the absence of magnet, it shows 0 volt. So the pulse count gets incremented, and the output speed of the wind is calculated in knots. And by using DHT11 sensor, temperature and humidity are calculated in degrees centigrade and humidity in percentage. And vibration is calculated by using ADXL 345 sensor. And all these data obtained from the sensor are stored using the cloud computing. Cloud computing is an application-based software which is used for storing the data. It consisting of a front end and a back end. Front end enables the user to access the data using an internet browser or a cloud computing software. In back end is responsible for securely storing the data. In cloud computing technique, we are using Node MCU D1 and then VAM server. Node MCU D1 is a development board. It is compact and versatile. It is very easy to use with Arduino boards. And VAM server, it is used for web development and internal testing. When the parameter exceeds the threshold value, an alert is given to the maintenance staffs, and emergency warning call is executed during the seismic events, which helps the people to save their lives.
Structural health monitoring system can improve the safety and reliability of the structures and reduces the maintenance cost. It's the damage detecting device for engineering structures including bridges, thus enabling the maintenance and repair actions to be implemented more effectively. We will give an emergency warning to call during the seismic events, thus people can save their lives. Here we are monitoring 5 parameters which are temperature, humidity, crack detection, vibration and high wind. For temperature and humidity we are using DHT11. For crack detection we are using ultrasonic sensor. For vibration, an electromechanical device which is called as MEMS accelerometer. For high wind, we are using Hall magnetic sensor. All those sensors are interfaced with 80 Mega 328. Mini Wi-Fi board is used, which is Node MCU D1 Mini. And coming to the software section, Arduino software is used to program the microcontroller.
Initially, we monitored parameter through LCD indication. Whenever parameter exceeds threshold value, the LEDs blink. In order to know the value to respective parameters, the LCD is connected and there be indicates there is a rise in value, reduce of value. The data are further stored in cloud through Node MCU. Whenever there is a rise in a parameter, the message alert is given to the registered mobile number.
Myself, Mahalakshmi, contributed to the preparation of a report by gathering content and source idea through books and internet, developed Arduino Uno based source code for respective sensor.
Contribution is hardware implementation of XCSR04 and Hall magnetic sensor and report alignment.
My contribution is hardware implementation of DHT11 sensor for temperature and humidity and ADXL345 sensor for vibration, gathering content and preparation of the report.
Contribution is implementation of message alert and preparation of report.